let's take a look at example 1 here and see what they're going to ask us. Before they ask us to evaluate, they're going to ask us to find the reference angle for each of these values. So can you even find it? And again, not meaning that they're going to be always nice reference angles. We'll get into that down the road where we may need to use a calculator to find the approximate value rather than the exact 1/2 or √3/2 or √2/2. But where's 294 going to put me? And as I mentioned before, draw visual picture of where you're located because it's going to help you a lot. And if you want to even label to kind of give you an idea, where is 294 going to be? That's in quadrant 4. And so what do we say to find the reference angle to quadrant 4? Remember, it's always going to be to the x-axis. So if I rotate it around 294 degrees to get to this point right here, I still want to be able to drop that down to my x-axis. And that would be what is called the reference angle. The actual angle that I went was 294 degrees to get all the way to there. But the reference angle is going to be 360 because that would be all the way around. I don't want that, so I'm going to subtract off the 294. And so you can either do some borrowing or just do the 36 minus 29, which would put us at 7D. Don't forget the 0. And then just subtract off the 4 to give us 66. So that would be a 66-degree angle that would be left. Now, some of you may have been able to just look at that without having to use some algorithmic problem-solving technique that we just used. And that's great, because if we're trying to get to 360, we know that if we added 6, we'd be at 300, and then we can just add 60 more to get to 360. So we knew we added 6 and 60 for a total of 66 degrees. So again, our reference angle, the symbol we use is that little apostrophe, and we get our answer of 66. That's what we would evaluate. If it were 60, we should know any and all of our trig functions. Okay, so negative 153, part B. Why don't you go ahead and give that a try? Do a quick sketch, and then try to see first what quadrant you would be in, and then secondly, what your reference angle would be. Again, always to the reference axis, the x-axis. So go ahead and pause it, give that a quick try, and then I'll go over it with you real quick and we'll move on. All right, hopefully you tried that on your own. Negative 153, don't be afraid by the negative, but don't forget it. That means we're going to start downwards. And I know that's more than 90, and I know it's more than that 180, so I'm going to be in quadrant 3. So that negative 153 degrees, I will just take that 180 I would have had to have gone, but then I'm going to have to figure out how much I need to come back to go that negative 153 degrees. So we'll simply just take the 180 and subtract the 150 and then 3. And again, hopefully you realize why I paused where I did. 180 minus 150 is 30, minus 3 more. We have a 27-degree reference angle. Now don't forget that reference angle for us is going to be positive, because if we went negative 27, that would have put us here in quadrant 4. All right, so pretty simple. Angles aren't the best. If this were a 60 and this were a 30, which is really close to those, then we could find any and all of our trig functions. But for now, just trying to practice how to find reference angles. So in example 2 here, they want us to find the values, all 6 trig functions for this angle 225 degrees. So what I'm going to start by doing is actually finding where that is located by, again, a simple drawing. And 225 degrees is definitely more than 180. but less than 270. So how much in between that would I be? Well, I recognize 225 as one of those reference angles in a different quadrant that we spoke about and listed. 225, I'd have to add 45 degrees to that, which means we would be right in the middle here to get to that point. How far? I don't know. They didn't tell me that, but they did tell me that I would have to rotate 225 degrees, which means I also know that the only trig function that's going to be positive is tangent. So right then and there, I know this, and this are all going to be negative, where tangent and cotangent, its reciprocal function, are going to be positive. And so all I'm really doing to find 225 degrees is I'm going to be evaluating the 45-degree angle by just dropping this perpendicular straight down. And now I have my 45, 45, 90, which if you need to draw it out, that's fine. Not necessary. Remember we said if this is 1, then this would be 1 because they're both 45 degrees and opposite those would be the same. And then this would be root 2 times as big. So I have all the things that I could possibly need in order to find any of my big three. And of course, if I know those, then I also will be able to find the reciprocal functions. So like I said, if you have them memorized, now when I have the 45-degree reference angle, I know the sine of 45, root 2 over 2. I'm done. I'm moving on to the next thing. Cosine, oh, by the way, is also root 2 over 2 because they're complementary functions. And 45 and 45 would give me the same values regardless. And then tangent, remember, is sine over cosine. So if I know these two, then I can just put that over that and I get 1. Tangent of 45 is the easiest one to remember. So in order to find all of the reciprocal functions, I'd simply have to do the reciprocal of each one of those values that we just found. Root 2 over 2 and 1, which means if I flip 1, I get 1. Remember, my signs aren't going to change. If you wanted to say that this was the negative, this was the negative, and you actually draw your axes out, that's fine. You'll get the positives and negatives as well. I just like taking care of them all at the beginning because when people start using reference angles, they start forgetting their signs because they're really just looking at a 45-degree angle, even though technically we went 225 to put us here in quadrant 3. Okay, so again, be careful with your signs, pay attention. Now, in order to take root 2 over 2 and flip it, remember we're going to get a 2 over root 2, which is something that we don't particularly like. So even though this is our answer, we don't know what root 2 is, so we don't like to divide by it. So we're going to take that 2 over root 2, and we're going to multiply it by a fancy 1 of root 2 over root 2, which would give us 2 root 2 on top and just 2 on bottom. And since these are multiplying, remember I told you the only time that you can simplify is when you're multiplying. That would then cancel out that 2 over 2 to be a 1. And if you had 2 root 2's and divide it by 2, you would only have 1 root 2, which is going to be our answer for the others. So now you might start to believe why I told you it's so important to memorize these things. I don't want to have to do all that ever again. Okay, so even though it asks us for all 6 trig functions, we're able to find these 3 and then do the reciprocal to find their reciprocal partners. So example 3 is going to emphasize a point that they're going to make. They want you to find the exact value of these things. And again, I put on there, as I just previously mentioned, don't forget to pay attention to the signs, positive and negative. Now you look at these two and they don't look that difficult. At least they're not asking us for all 6 of a particular angle, but I don't necessarily like the first one because it has a negative angle. I prefer positive positive things. And then I don't like the fact that it's 780 degrees. I know if I make a full circle around, I would get 360 degrees. So anything more than that is just meaning that I'm going around further and still going to end up somewhere along that same circle. So we're going to have to find a little thing called, let's see if you're learning your vocab, what kind of angle would be equivalent to 780 degrees that would put us in the exact same position. Hopefully you said coterminal, same ending, all right? So that's why we learned that in the previous. We're gonna now have to utilize that and then evaluate for cotangent. And if you don't like cotangent, you can always find tangent and do the reciprocal very quickly, okay? So like I mentioned previously, what helps you to see what you're dealing with? Drawing it. So I'm gonna draw some axes real quick for us. So now I can start drawing these angles. And remember, we always initially start, called the initial side, from the origin, facing the positive x direction. And because this one said negative 150, I'm gonna have to go downwards first. And I know that I'm gonna be using the 180 as my reference, and I know I'm not quite going 180, so I'm gonna have to go 180 and come back how much to only be 150? Hopefully you all said 30 degrees. And that really is what I'm looking to find. Okay, so if you know that this is equivalent to the sine of 30, then you're all good. And the sine of 30 is equal to 1/2. However, that's incorrect. Now, if you want to double check what the sine of 30 is, yes, you can pull out your calculator, but don't forget it asked for the exact value. They don't want you to use approximations like decimals. They want the exact fraction, okay? Even though 0.5 is the same, the square root of 3 over 2 is an exact answer. Punch in the square root of 3 over 2 in your calculator, you're going to get a big old long string of decimals that never ends and never repeats. So that's called the approximate, all right? So know the difference between an exact answer and what they're looking for and an approximate, which we will get into later. So why is 1/2 incorrect for the sine of 30? Well, don't forget, guys, I mentioned it several times and will again, got to pay attention to your signs. I know that all students take calculus that are in this class. So I know the only thing, even though we rotated technically negative 150 degrees to get to that point, when I draw to my x-axis that right triangle, it's really going to be a 30, 60, 90, and I'll be using that 30-degree angle, which I now know is 1/2, but don't forget that it should be negative. Okay, so again, just trying to hit that point home. If you don't believe me, go ahead and punch in the sine of negative 150. Just make sure that your calculator is in degrees before you hit it. Hit the equal sign and you will see a negative 0.5, right? But you won't always be given the exact value, so we want to make sure that we can do this by hand because there will be times that you won't be able to use a calculator. So the cotangent of 780, I would like you all to just try on your own very quickly. So go ahead and pause it right here, come back, and I'll walk you through it. All right, so looking at the 780 degrees before I even think about cotangent, I want to see where that is, so I'm going to do a drawing to see it. Now, when I do this, remember 780 degrees means I'm going to have to go all the way around at least once. That's 360. What if I went around 360 another time? Well, hopefully you remember from early on, we did things like this. 360 twice, I know 300 twice is 600, and 60 twice is 120. So that's a total of 720 degrees. If I just went all the way around this circle and ended up right back where I started. So I'm just going to flat out start by subtracting off those 2 extra rotations or revolutions around to get an equivalent statement of 60 degrees. So rather than finding the cotangent of 780 degrees, which made me rotate around this twice, I can just go 60 degrees and end up at the exact same spot, which is really nice because that puts us in quadrant 1, which first of all, we know everything's positive in quadrant 1. And then secondly, we don't need to figure out what our reference angle is. It's already given. So all you need to know is either, listen to that statement, either what the tangent of 60 is, so that you can then take that and do the reciprocal of to find the cotangent of 60, or you can use the fact that we know it's a cofunction, and you could actually find the tangent of 30 degrees, which is equivalent to the cotangent of 60 degrees. And so because I know these off the top of my head, I have memorized them, I've taken the time, I know the tangent of 30 is root 3 over 3, which means cotangent of 60 is also root 3 over 3. So just to prove it to you real quick, hopefully you remember the tangent of 60 was just root 3. So if we did the reciprocal to get the cotangent of 60, we'd have to flip that and then multiply by that fancy 1 to get our root 3 on top and 3 in the denominator. That just takes more work, which is why at the beginning of this, we talked about cofunctions, reciprocal functions, all of that. It's all going to come in handy at certain times or another. And the more that you understand and memorize, the better off you're going to be. All right, so the fourth example has a pretty nasty trig expression. Now, not an equation because there's no equal sign. It's what is called an expression. And remember, I warned you guys about these little squared parts. So what I'm actually going to do is I'm going to rewrite this in a little bit better form. I'm going to write the sine of 45 squared plus 3 cosine of 135 squared minus 2 times the tangent of 225. So the bad news is I have 3 different angles for 3 different trig functions. So I'll start with the sine of 45. And I'm going to go ahead and draw that over here. Now for this, I don't really need a drawing because I have it memorized, right? I know the sine of 45 to my reference angle would mean that this is a 1, this is a 1, and that's a root 2 length. And I know sine is opposite over hypotenuse. So the opposite over the hypotenuse would give me that, which would result in that value, always and for any 45-degree angle for sine. So I can now evaluate what the sine of 45 is. Just don't forget your sines. I mentioned it last time, I'll mention it again and throughout the course. It's positive because we're in quadrant 1. But the other two are not necessarily. So the next one I'm looking at now is the 3 times the cosine of 135 quantity squared. So I now need to find the cosine of 135. So when I go to draw this out, I already know that that's less than 180 and more than 90. And 135 means I'm going to go 180 back 45 degrees or 90 plus 45. However you get there, just make sure you get there for that reference angle. Now, before I do anything else and start evaluating or thinking what ratio comes out for sine, cosine, tangent, or whatever, I'm going to make sure I take care of my sines. Now, you would have been lucky if you didn't for this one, but because we're dealing with cosine, I know it's going to be negative. And I mean lucky because we're going to be squaring it. And so that negative is going to be lost anyways. When we square a negative, we know we get a positive. So you would have gotten lucky. But again, you got to be careful and make sure you look for these things. And then lastly, what is the cosine of 45 degrees, which remember is our reference angle? Even though we technically rotated 135 degrees, we're just going to use that 45 that we could then draw our right triangle and know all of those ratios. Again, 1, 1, and the square root of 2 for our hypotenuse. So we should know it's the square root of 2 over 2, just like it was for sine of 45. Just don't forget we're in a different quadrant, so this time it's negative. So the last one we have to do any work on is tangent. And for tangent, we have to, again, be careful when working it out and putting ourselves in the proper quadrant. So 225, I know, is more than 180, but less than 270. And how much more or less? Hopefully you recognize if it ends in a 5, it's probably going to be a 45. If it ends in a 0, it's probably a 30, 60, 90 scenario. So 180 plus 45 is indeed that 225 degrees. We would have had to have rotated, but remember it was that extra 45 that we're going to reference to our x-axis to get, again, a 45, 45, 90. This is why I spent the time to go over it. It's very important for us to understand. And get your signs first. Good. Tangent. That's what we're dealing with. So it's positive, because this one would have mattered because this one is not squared like the other ones were. And then what is the tangent of 45? Hopefully you remember it is the easiest one to memorize because it is 1. So all we have left to do is simplify this by our order of operations. So first I will work on squaring the top and bottom of this. So squaring a square root will bring it out. Squaring a 2 will give me a 4. I'm going to go ahead and put the 3 is over 1 because I know when I square this, it's going to be positive. Then I'm going to be multiplying by. And then squaring that and that gives me my 2/4 again. And then minus 2 times 1, a positive 1. If that were a negative, then that would have changed my sign right here. So be careful with that. So negative 2 times 1 is negative 2. So simplifying that, my next step would be 1/2 plus, that also becomes 1/2. But since I'm multiplying it by 3, it becomes 3/2. And then minus 2, I'll go ahead and multiply this by 1 to get my common denominator. So I'll make a different looking 2. So now I will take this and figure out what it is equivalent to for my final answer. And if I take 1/2 and add 3/2, I get 4/2. And if I subtract 4/2, I actually get an answer of 0. So this definitely did not look like nothing at the beginning, but after evaluating, we found out that the answer would actually come out 0. Okay, so again, be careful with the signs, finding your reference angles in the proper quadrants, and then evaluating it according to our order of operations. Because there's a second part to this that I wanted to do, part B, but I want you guys to try this one before I just go over it, because it's just going to practice your order of operations and evaluating trig functions. So go ahead and pause it, give it a try, and then I'll come back and do it with you really quickly. All right, so hopefully you tried that on your own and saw that it is indeed false. In other words, we cannot distribute a trig function. That does not work, and this is basically just proving that with what is called a counterexample. So how should you have known? You should be able to evaluate these two things. And then this we can do. So it's just going to be the sine of 90, which is a quadrantal angle, which if they don't tell us what the radius is, we'll choose a radius of 1 because it's the easiest one. And therefore we know that point. So evaluating all of this, again, if you have it memorized, boom, done, 1/2 immediately. And if you know that 30 and 60 are complements of each other, you know if it's not 1/2, then it's the other. With the 30, 60, 90, you'll have the 3's involved, root 3 over 2. With the 45, 45, which has the two angles that are the same, it has the root 2 involved. Okay, and then the sine, remember, is always the y over the r. So my y over my r would be 1 over 1. Sine of 90 is 1. Again, hopefully you memorize that. Now, Only time that we can add are when we have like terms. So when I add these halves together, I'll take 1 plus root 3, which is 1 plus root 3, which is definitely not equal to 1, because the top would have had to have been a 2 in order to make this true. Okay? So the point of this example, this demonstration, was that you cannot distribute trig functions. They don't work like normal variables. They are functions. Okay, a little bit different. All right, so example 5, we're almost done here. Bunch of different types of examples that I'd like to get through is I want you to evaluate this by first rewriting it with that coterminal angle, and then hopefully you will be left with a nice reference angle like a 30, 45, or 60, and then evaluate for sine and cotangent. All right, and just by looking at part A, hopefully you see that ends with a 5, so I'm thinking already 45-degree reference angle. In part B, it could be a 30 or a 60. So first things first, pause it, try it on your own, then come back. I'll go through it really quickly. All right. Hopefully you all gave that a decent attempt. And the first thing you should have done was add or subtract 360 as many times as you need to get an angle between 0 and 360. Right? We don't need to rotate around any more than one full circle. We'll get to the same places. All right. Next thing you needed to do once you got your 225 and 150 by subtracting 360 here and adding 360 a 3x multiple, which came out to 1080. Because it was a negative, we wanted to get it to be positive. We added 360 3 times and got 150. Now all we have to do is figure out where those are located. So all I'm going to do is draw a quick sketch just to try to hit this home again, because it's still kind of new. And I'm going to know that I'm going to have to add an extra 45 degrees to get to that point. So this is actually also equivalent to the sine of 45 degrees. Now, if you put that, be very careful. Remember, you're not actually at 45 degrees. We are actually located here at this point. So, of course, take care of your signs. No pun intended. Because the sine of 45 is root 2 over 2. As long as we got that negative there, we know the answer to the sine of 585 is the same as 225. So the last one here, cotangent of 1080, we added on to that negative 930 to get 150. So now all we have to do is figure out where that is located. And I know that is 30 degrees less than 180. But remember, we also know that since it's cotangent, the reciprocal of tangent, it is going to be a negative answer. And instead of finding 30 degrees and using tangent and then having to flip it, which we could do, remember we said we could also find the reciprocal function of tangent, which is cotangent, but we could also use cotangent as its cofunction. So since this is actually equivalent to the cotangent of 30 degrees, but negative, we can then evaluate the cotangent of 30, which if you don't know, you can also evaluate its cofunction counterpart, which is equivalent, the tangent of 60. So our final answer is definitely don't lose the negative, but the tangent of 60 is square root of 3. Here's the sixth and final example that I wanted you guys to be able to work out, hopefully on your own. Give it a try. This time we're working backwards. This time we wanted to make sure that you could find all the values for the angle in one full circle, including 0, that's why the bracket's there, and excluding 360, because remember they are the exact same point, for these ratios. So if I'm asking you to find the angle for cosine that is negative, you should already know that we're narrowed down to quadrants 2 and 3, because I know cosine is positive in quadrants 1 and 4. So I definitely know that I'm going to be in either quadrants 2 or 3 for my answers for theta, but I also need to find the reference angle for cosine that gives me root 3 over 2. So if you have that memorized, great. The one that I often tell students to memorize is the sine of 30, because it's pretty easy. It's 1/2. So if I know the sine of 30 is 1/2, then I also know that the sine of 60 is the other 30, 60, 90 ratio, root 3 over 2. And if we know those, then we also should know that the cosine that's equal to 1/2 would be the co-function and therefore complementary angle. And then if you know that, then the cosine of 30 is also equal to root 3 over 2, which means I then know my reference angle is 30 degrees in these two quadrants. And since we're doing everything to the x-axis, all we'll have to do is subtract 30 from 180 and add 30 from 180. And by doing that, we just found our two possible answers were 150 and 210, which again should look familiar. So do me a favor, go ahead and pause this, try part B. I'll explain it if you need it. Otherwise, I feel like hopefully going through all of these different types of examples, really harping on memorizing these and paying attention to your signs, depending on the quadrant, you should be off and running with the homework for practice until you master it. So go ahead and pause it, give part B a try, last one for this, then we're done. All right, hopefully you were able to figure that out. If not, let me do a quick explanation of finding your quadrants first. Because I know tangent is negative, I'm going to X out where it's positive. So I know I'm in quadrants 2 and 4. Then all I have to do is figure out for tangent what angle gives me root 3. I've already taken care of the negative, the sine. Now I need to find the reference angle that gives me root 3. And we've done that a few times today. Hopefully you're starting to memorize these already. That would be 60. Now don't forget, this one's going to be from the x-axis over here at 180. And then this one's going to be from the x-axis over here, 360. So your two angles for the answers for tangent that would give us a negative root 3 value would be 180 less 60, 120 degrees, and then 360 less 60, which would be 300. And now hopefully you see why I went over some of these angles earlier to try to let you guys start getting familiar with the types that you're going to see over and over again. So that's it for this installment. Hopefully you guys got a lot out of it. Like I said, reference angles, super important, something that you're going to want to really work hard to understand, and then start memorizing the 30, 45, and 60 for your big three: sine, cosine, and tangent. And if you want to further that even more, once you have those memorized, do it also for cosecant, secant, and cotangent. The more you have memorized, the better off you'll be. The quicker you'll be able to move through these. That's it. You guys have a good one. Take care. Alan, gone.